Hello, it's me again, Sam Moore, and we're going to continue our exploration of the guts or the internals of your electric guitar. And we're going to figure out how to make that rascal work and how it works. And we're going to do it as much as we can without using a whole lot of math. It occurred to me the other day that if you're going to make your own adult beverages, sometimes it becomes necessary to transfer the contents of one of your jugs to another one. And how do you do that? How do you move that from one jug to another one? Well, you use a gadget called a siphon or a tube. I happen to have a tube that may or may not have been used to transfer the contents from one jug of adult beverages to another at some time or other in the past. I don't know for sure, but it's possible. Okay, last time we talked about voltage division and about how if you have a potentiometer, and I should say at this point, should have said it last week, but I can't think of everything, that most people shorten that to just pot. Now, it ain't that kind of pot that you're thinking of. It's just short for potentiometer, and they just call it pot. It's easier to say, it's easier to spell, just easier to get along with. That if you have a potentiometer this big and you apply this many volts across the whole thing, if you look at the volts across just half of it, you're going to see half the voltage, and across 3/4 of it, you're going to see 3/4 the voltage. The whole thing, you see all the voltage, a little bit of it, you just see a little bit. And that's how your volume control works. You move that wiper up and down along the turns of that pot, and that varies the voltage that you see over here, which goes to your output jack. Today we're going to talk about AC, or alternating current. Now, why are we going to talk about that? Okay, we're going to talk about that because AC, or alternating current, is what shakes the speaker. Okay, that's what makes the sound that you can hear is AC. I'm sure you've heard probably your whole life people talking about AC because it's also the kind of power that comes out of the wall. There are many reasons for power to be transmitted in the system as AC, some good, some bad, but that debate was held years ago and AC won. Sometimes they use a little bit of DC here and there, but overall they use AC. Okay, your AC waveform, or what it looks like if you were to actually look at it on some of the instruments that have been invented or developed for use in electrical circuits, looks like this. Now I'm going to have to take my camera down and move in close, so once again you're not going to get to see my beautiful smiling face for a bit, but I'll be right back as soon as I get everything moved. Okay, here's my beautiful AC waveform, courtesy of Microsoft MSDN, whoever that is. And like Mike posted this one, so thanks, Mike. I appreciate your AC waveform and your animation. Pretty cool, really, if you look at it. Okay, this is the voltage right here. This is the voltage coming out of your guitar. Now you'll note, it starts at 0, it goes up, it goes down, and it comes back to 0. 0, up, down, back to 0. Constantly changing, constantly moving, constantly changing in time. So, since I want to be able to see that and talk about it, I'm going to change one that's frozen in time, okay, that's not moving, so it's not dodging on me here. Okay, here's one that's not moving. Starts at 0, the voltage goes up to a positive peak, down back to 0, then down to a negative peak, and then back to 0, and just repeats over and over in time, over and over. Okay, there's a couple terms that we have to be familiar with when we talk about the AC waveform. Amplitude, that's the first one. Now that's a tough one. Amplitude, that's just fancy talk for how big is it, okay? See this one? That's the amplitude of this one. If I were to look at a different one, it would have a different amplitude. But amplitude, just the size of the waveform. In other words, the volume level. How loud is it? Okay. Frequency. You see these wiggles? That voltage is wiggling, you know, it goes up and down and up and down and up and down. Frequency is a measure of how many wiggles that waveform makes in one time, in 1 second. Now, let me walk over here. Okay. Come on there, you. What does that mean to us? Here's a low frequency. Here's a high frequency. You're going to think of them as notes. If you're a guitar player, you're going to think of as notes. Low frequencies are low notes. High frequencies are high notes. That was complicated, wasn't it? Okay, there's one more tricky thing we have to look at is the period. Okay, the period is how long. Now this is a measure of time. This is not how many wiggles in 1 second. This is how many seconds in one wiggle. So how long does it take to go from that peak to that peak? From this zero crossing where it's going up to this zero crossing where it's going up. From this zero crossing where it's going down to this zero crossing going down. Those are all equal. They're all the same time. But the important part is from the same point on the first wave to the same point on the second wave. It's called the period. The period is equal to 1 over the frequency. The frequency is equal to 1 over the period. You don't need to memorize that. You don't need to know that. I just threw it in as a little extra. You can take that to parties. Yeah. Tell your girlfriend at the next party you're at, or your boyfriend, or your whatever. Don't tell your mom at the dinner table. She's going to get upset with you. She'll be saying, I don't like that kind of talk at the dinner table. And, you know, you have to go through all that. But you can impress your friends with it at the next party you go to. Okay, now let me move back to where I can put my smiling face in here again. Okay, now you're an expert on AC. How can AC do anything, you might ask, because, it's going this way and then it's going this way and it's going this way and it's going this way. It's always switching back and forth and going from one to the other. Well, if you remember, we talked about voltage being a potential energy. A potential energy. Okay. It's the ability or capability of doing work. It turns out that when that voltage is dropped across a component, that the voltage or the potential energy is converted to work. Doesn't matter which direction it's going, whether it's going this way or this way or this way or this way, it's doing work. Think of it like a box sitting down on the ground. If you push this box this way, you're doing work. You push it this way, you're doing work. You're working against the friction of that box sliding across the ground. If you stand there and you push that box back and forth 100 times all day long, you're going to be tired at the end of the day. Your little pink tongue's going to be hanging out. You'll be sweating, you may be drooling a little bit because you've done a lot of work pushing that box back and forth. Well, it's the same thing with AC. It's doing work by pushing that current back and forth, back and forth. Okay. Now, there's a couple other terms that you probably want to hear, probably want to know about. Well, I already talked about the frequency, how many wiggles per second. Musicians talk about overtones, first overtone, second overtone, third overtones. Engineers talk about harmonics. Guess what? They're talking about the same thing. They just call them by different names and they count them a little bit differently. If you have a waveform with this frequency, that's referred to as the fundamental frequency. A waveform with twice that frequency, in other words, it makes 2 wiggles, and the time that this one makes 1 wiggle, then that is the second harmonic. It's the first overtone. The first overtone is the second harmonic. Okay, so they're always different by 1, but harmonics and overtones are the same thing. Let's review real quick because my battery's dying on me. We talked about amplitude. We talked about frequency or wiggles per second. We talked about period, seconds per wiggle. We talked about harmonics and overtones. Next week we're going to talk a little bit about Fourier analysis and big scary word, but we're going to simplify it and make it as easy as we can. Before I go, I want to say, hey, subscribe. Tell your friends if you're enjoying the series. Tell your friends. Let them in on the fun too. If you're not enjoying it, who cares? Don't watch. Till next week, keep on picking.